Since the dawn of time, humanity has been driven by an insatiable curiosity, a deep-rooted desire to explore the unknown, to chart the uncharted, and to unlock the mysteries of the cosmos. From the early days of stargazing, when our ancestors looked up at the night sky in wonder, to the modern era of space exploration, this quest has been a defining feature of our species. It is the reason why we have crossed oceans, climbed the highest peaks, and ultimately looked to the stars with dreams of reaching them. Now, we invite you to close your eyes and allow yourself to be carried away by the story of our exploration of the universe. The cosmos, with its boundless expanse, has always been a source of inspiration and intrigue. As we advanced in technology, our aspirations grew bolder. We yearned not only to observe distant worlds from afar, but to venture into the depths of space itself, to send our creations beyond the confines of Earth's gravity and into the vast unknown. It is this spirit of exploration that led to one of the most ambitious undertakings in the history of space exploration, the Voyager missions. In the early 1970s, NASA embarked on a mission that would push the boundaries of human knowledge and engineering. The Voyager program was conceived as a daring endeavour to explore the outer planets of our solar system: Jupiter, Saturn, Uranus, and Neptune. The plan was simple yet audacious: to send two spacecraft, Voyager 1 and Voyager 2, on a grand tour of these distant worlds, gathering data and images that would revolutionize our understanding of the solar system. The timing of the Voyager missions was crucial. The late 1970s presented a rare alignment of the outer planets, a cosmic event that occurs only once every 176 years. This alignment would allow a spacecraft to slingshot from one planet to the next using gravitational assists, a technique that could save time and fuel and enable a single mission to visit multiple planets. Scientists and engineers worked tirelessly to design spacecraft that could survive the harsh conditions of space, operate autonomously, and transmit data back to Earth over vast distances. Each Voyager spacecraft was equipped with a suite of scientific instruments, including cameras, magnetometers, spectrometers, and plasma detectors. These instruments were designed to study the atmospheres, magnetic fields, rings, and moons of the outer planets. But the Voyagers carried more than just scientific instruments. Each spacecraft was also equipped with a special cargo: a golden record, a time capsule containing sounds and images that represented the diversity of life and culture on Earth. These records were intended as messages to any intelligent life that might encounter the spacecraft in the distant future, long after they had left the solar system. Voyager 2 was the first to launch on August 20th, 1977, followed by Voyager 1 on September 5th, 1977. Although they were launched in reverse order, Voyager 1 was set on a faster trajectory and would overtake its twin to become the first to reach the outer planets. As the Voyagers began their journey, scientists eagerly anticipated the data they would send back. What they discovered exceeded all expectations. The flybys of Jupiter and Saturn revealed a wealth of information about these gas giants and their moons. Voyager 1 arrived at Jupiter in March 1979, followed by Voyager 2 a few months later. The spacecraft provided stunning images of Jupiter's swirling cloud bands and its Great Red Spot, a massive storm larger than Earth that has raged for centuries. The Voyagers also discovered active volcanoes on the moon Io, the first time active volcanoes were observed on another body in the solar system. They mapped the icy surface of Europa, hinting at a subsurface ocean beneath its frozen crust, a finding that would later spark speculation about the potential for life on this distant moon. Next, the Voyagers journeyed to Saturn, arriving in 1980 and 1981. They captured breathtaking images of Saturn's rings, revealing their intricate structure and the presence of shepherd moons that help maintain the rings' sharp edges. The spacecraft also provided the first close-up views of Saturn's largest moon, Titan, shrouded in a thick atmosphere of nitrogen and methane. While the dense atmosphere obscured Titan's surface, the data hinted at the presence of liquid hydrocarbons, possibly lakes or seas, on its surface. Voyager 2 continued its journey to Uranus and Neptune, becoming the first and only spacecraft to visit these ice giants. At Uranus, in 1986, it revealed the planet's featureless pale blue atmosphere, its bizarrely tilted magnetic field, and its moons and rings. The flyby of Neptune in 1989 was equally thrilling, revealing dynamic weather patterns including supersonic winds and the mysterious Great Dark Spot, a massive storm similar to Jupiter's Great Red Spot. Each planetary encounter was a milestone, expanding our understanding of the solar system in ways that were unimaginable before the Voyager missions. The data they collected challenged existing theories and opened new avenues of research, inspiring generations of scientists and astronomers. While the primary mission of the Voyagers was to explore the outer planets, the spacecraft were designed with a secondary mission in mind: to venture beyond the planets and into interstellar space. After their encounters with Neptune, Voyager 2 and its twin Voyager 1 continued their journeys, heading towards the edge of the solar system. By 1990, Voyager 1 had travelled so far from Earth that it was commanded to take one last photograph of the solar system, a family portrait that included Earth as a tiny dot, famously known as the pale blue dot. This image, taken from a distance of 3.7 billion miles, serves as a humbling reminder of our place in the universe. As the Voyagers moved farther from the Sun, they crossed into a region known as the heliosphere, the vast bubble of charged particles and magnetic fields that surrounds the solar system. Voyager 1 crossed the boundary of the heliosphere, known as the heliopause, in 2012, becoming the first human-made object to enter interstellar space. Voyager 2 followed suit in 2018. In this new frontier, the spacecraft continued to send back valuable data about the interstellar medium, the space between the stars, providing insights into a region of space that had never been explored before. Today, more than 4 decades after their launch, the Voyager spacecraft continue to communicate with Earth, although their power supplies are dwindling. The nuclear-powered generators that keep the instruments running are slowly losing energy, and within the next few years, the spacecraft will no longer be able to send data back to Earth. But even as their mission draws to a close, the legacy of the Voyager missions endures. The Voyagers have travelled farther than any other human-made objects in history. They have journeyed through the realms of the giant planets, captured the imaginations of people around the world, and provided a treasure trove of scientific data that continues to shape our understanding of the solar system and beyond. Their discoveries have rewritten the textbooks and inspired countless new questions about the nature of the universe. As we look to the future of space exploration, the Voyager missions serve as a testament to human ingenuity and curiosity. They remind us of what we can achieve when we dare to dream big and push the boundaries of what is possible. Long after they have gone silent, the Voyagers will continue to drift through the cosmos, carrying with them the story of humanity's first steps into the interstellar void, a story that will endure for eons. The Voyager missions are more than just a triumph of engineering and science. They are a celebration of the human spirit. They represent our desire to explore, to seek knowledge, and to understand our place in the universe. As the Voyagers continue their silent journey through the stars, they remind us that the quest for discovery is endless, and that the greatest adventures are often those that take us farthest from home. And so, we bid farewell to these remarkable explorers, knowing that their contributions to science and humanity will echo through the ages. The Voyager missions have shown us the wonders of our solar system and opened the door to the stars. They have taken us on a journey that transcends time and space, a journey that will continue to inspire future generations to reach for the stars and beyond. If you liked this episode, don't forget to subscribe and give it a thumbs up, which really helps with the YouTube algorithm. Comment what you want us to talk about in our next video and stay tuned for more explorations into the mysteries of the universe.